Hello everyone, in this video we're going to learn how to integrate 1 over s to the 6 minus 1 ds. Alright, so we see that this is the power 6. We need to bring this power down by using the difference of 2 square. So it's going to be integral of 1 over s to the third square minus 1 ds. Alright, so I'm going to use the difference of 2 squares. It turns out to be ds over s cubed minus 1 times s cubed plus 1. Now next one, we need to use fraction decomposition to split this guy up. Alright, so it turns out to be the integral of, now this one we just write as power of 3 plus 1 minus s power of 3 plus 1 over s power of 3 minus 1 times s power of 3 plus 1. Put ds right here. So you look at the top, you just literally multiply the top by 2, so you need to divide this guy by 2, so things doesn't change, right? Now, this one right here, I just group this guy and this guy. And then this guy, I group this guy and this guy. I need to change this side into subtraction side. So this guy turns out to be 1/2 the integral of ds over s cubed minus 1 minus the integral of ds over s cubed plus 1. Alright, now I call this one is d1. I call this is d2. Now I need to calculate d1 first. So I have d1 equals the integral of ds over s cubed minus 1. Alright, so in order to do this one, I need to expand the bottom. So it turns out to be the integral of ds over s minus 1 times s squared plus s plus 1. Alright, I just use the formula difference of 2 cube. A cube minus b cube. It's going to be a minus b times a squared plus ab plus b cube. Alright, so if you have the addition side right here, and then this guy turns out to be addition side, and this guy turns out to be subtraction. So keep that in mind. So in order to calculate the integral of this one, I look at the bottom right here. I see this one as minus 1, right? So I just rewrite this one as minus 1 right here. Now ds is the same thing as d of s minus 1, right? Now the bottom right here, s squared, I rewrite s squared. Now s right here, I just split this one into negative 2s plus 3s, right? Now 1 right here, I just put 1 right here. Alright, so I have 3s left right here. Now you know that the first three terms right here is going to be complete square, s minus 1 altogether square. So I have 3s right here. I need to subtract 3 so that when I factor 3 out, it's going to be s minus 1, right? So I just subtract 3, I need to add 3, right? And you see that everything in the bottom right here doesn't change, right? Now this guy turns out to be the integral of ds minus 1 over s minus 1 times the first three terms right here turns out to be s minus 1 altogether square. The next two terms right here, I just factor 3 out, so it could be plus 3 times s minus 1. And then you're going to add 3 right here. Alright, so now I'm going to use substitution, right? So I just let t equal s minus 1. So this guy turns out to be dt over t times t squared plus 3t plus 3, right? Now next one, I need to use fraction decomposition to split this guy up. So this guy turns out to be t squared plus 3t plus 3. I just rewrite t squared plus 3t plus 3 on the top. Okay. Then I'm going to subtract t squared plus 3t. Right? So if I do like this, I have 3 on the top, which means I need to multiply by 1/3 right here. Over t times t squared plus 3t plus 3 dt, right? Now I'm going to split this guy up. So this guy turns out to be 1/3. Now this guy divided by this guy, it turns out to be the integral of dt over t minus, now the second one, I have the integral of t squared plus 3t over t times t squared plus 3t plus 3. Now look at this one right here. I can divide the top and bottom by t. So this guy gone. The top right here, I only have t plus 3, right? Now, observe that if you take the derivative of the bottom, it's going to be 2t plus 3, right? I only have 2, but I only have t's right here, so I need to multiply the tops by 2 so that I have 2t's, right? So because I just multiply by 2, I need to divide by 2 so that things doesn't change. Now this guy turns out to be 1/3 of the integral dt over t minus 1/2 right here. Now this one right here, I just split this one. Now if I take the derivative of this one, it turns out to be 2t plus 3. Now if I multiply this one, it turns out to be 2t plus 6. So 6 right here, I can split this one into 3 plus 3, right? So I just rewrite this one as the integral of 2t plus 3 over t squared plus 3t plus 3 dt, right? And I'm gonna add 3 over t squared plus 3t plus 3 dt, right? Don't forget the integral, and don't forget parentheses right here, and the whole parentheses right here. Alright, so this guy turns out to be 1/3 of the integral of dt over t minus 1/2 the integral of 2t plus 3 over t squared plus 3t plus 3 dt. Now this one right here, I can make the bottom as complete square. So I just divide 3 by 2 and then square, right? So this guy turns out to be t squared plus 3t plus 3 over 2 all together square, right? And then I just add 3 over 2, which means I add 9 over 4, right? So this one I just rewrite plus 3, and then I need to minus 9 over 4, right? So this guy turns out to be t plus 3 over 2 all together square plus now this one right here you just simplify, so it turns out to be 3 over 4, right? So you have the formula. If you need to take antiderivative of du over u squared plus a squared, it's going to be 1 over a tangent inverse of u over a plus c. Alright, so u in this situation is going to be t plus 3.5, right? So this guy turns out to be plus the integral of 3 dt over t plus 3.5 altogether square plus 3 over 4 I can write root 3 over 2 altogether square, so that I can apply the formula right here. Alright, so this guy turns out to be 1/3 of natural log of absolute value of t, right? Minus 1.5 of natural log of absolute value of t squared plus 3t plus 3, right? Plus 3, use this formula 1 over a, which means 1 over root 3 over 2, which means 2 over root 3. So this guy turns out to be 3 times 2 over root 3. Tangent inverse of t plus 3.5 is going to be 2t plus 3, right? Over a which means root 3 over 2, and you have 2 right here, right? So now we need to simplify this one right here. So this guy's right here turns out to be 2 root 3 tangent inverse of 2t plus 3 over root 3, right? Now remember that we just use substitution by using t as s minus 1, right? So we just substitute s minus 1 back over here. So it turns out to be 1/3 parenthesis natural log of s minus 1, right? Minus 1.5 natural log of absolute value of s minus 1 altogether square plus 3 times s minus 1 plus 3, right? And then plus 2 root 3 tangent inverse of 2 times s minus 1 plus 3 over root 3 plus c, right? Now I distribute 1/2, so this guy turns out to be 1/2 multiplied by this, and then this guy turns out to be root 3 only, right? Now I need to combine this guy and this guy using the formula log base A of B minus log base A of C. It's going to be log base A of B over C. So before I'm going to condense this one and make sure the coefficient in front of natural log should be 1. So I have 1/2 right here. I cannot do it. So I need to multiply by 1/2 and 2, right? With 1/2 multiplied by 2 is still 1, right? Now 2 right here, I just print back over here. I have log base A of B power of K. It's going to be K log base A of B. Alright, so if you print K back over here, it turns out to be this one right here. Alright, so I can print 2 over here. So this guy turns out to be 1/3 times 1/2 natural log of absolute value of s minus 1 squared. This could be s squared minus 2s plus 1, right? Minus 1/2 natural log of. Alright, we're going to simplify this one. So if we simplify this one, it turns out to be s squared plus s plus 1 absolute value, right? Plus root 3 tangent inverse of, simplify this one, so this guy turns out to be 2s plus 1 over root 3, alright, altogether plus c, right? Now I factor 1/2 out, right, and I multiply by 1/3, so it's going to be 1 over 6. And then this one right here, I use the formula right here. So it turns out to be natural log of absolute value of s squared minus 2s plus 1 over s squared plus s plus 1. Alright. Plus 1/3 multiplied by this one is going to be root 3 over 3 tangent inverse of 2s plus 1 over root 3 plus c. Sorry, there is a typo right here. When we distribute negative 1/2, so this guy must be negative, this guy must be negative. So we have this guy right here must be negative. Alright, so we just calculated the integral of ds over s cubed minus 1 equals 1 over 6 natural log of absolute value of s squared minus 2s plus 1 over s squared plus s plus 1 minus root 3 over 3 tangent inverse of 2s plus 1 over root 3 plus c, right? So if we do the exactly same thing, right, we will have d2 is going to be the integral of ds over s cubed plus 1. It's going to be 1 over 6 natural log of absolute value of s squared plus 2s plus 1 over s squared minus s plus 1 plus root 3 over 3 tangent inverse of 2s minus 1 over root 3 plus c. Alright, so I'm going to leave this for you to calculate. So just give you a choice. You do exactly the same thing, the same process, you get the same answer right here, okay? So now I need to combine this one. So finally I need to calculate 1/2 of d1 minus d2 right here. I have the integral of 1 over s to the 6 minus 1 ds equals 1/2 d1 minus d2, right? So I multiply 1/2 right here. It turns out to be 1/12, right? So I have 1/12. parentheses. Alright, I'm gonna group this guy. Natural log of absolute value of s squared minus 2s plus 1 over s squared plus s plus 1. Alright, minus natural log of the bottom one right here, absolute value of s squared plus 2s plus 1 over s squared minus s plus 1. Close parenthesis. Alright. Now next one, we have 1/2 multiplied by this one. It turns out to be root 3 over 6, right? So I'm going to factor root 3 over 6 out. Minus root 3 over 6. Alright, parenthesis. This guy turns out to be tangent inverse of 2s plus 1 over root 3 plus tangent inverse of 2s minus 1 over root 3 plus c. Right? So this one right here, I can apply the formula log base a of b minus log base a of c equals log base a of b over c. So this turns out to be 1 over 12. Natural log of absolute value of s squared minus 2s plus 1. Right? Divide by this one, which means you multiply by its reciprocal, which means s squared minus s plus 1 over s squared plus s plus 1 right here. Multiply by this guy right here, s squared plus 2s plus 1, right? Absolute values. Subtract root 3 over 6 multiplied by tangent inverse of 2s plus 1 over root 3 plus tangent inverse of 2s minus 1 over root 3 plus c. And this is the final answer for this one. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.